Sometimes I'm afraid to go live because I realize I got no plan. And I got to do a bunch of cool stuff. And I don't know what to do. But you know what? We just got to jump in because once I'm in the thick of it, once I'm like in it, it'll be easy. So, okay, here's the main plan. So I do want to replace this part because I printed it. Where's my necklace? Where's my chain at, bro? I have a chain. Hold on. I gotta clean up my desk. I have this chain. This is one of the parts. I think there's another part, but I'm not gonna replace that part. This is the main part that we need to replace, but I'm probably gonna actually replace it even again. So okay, so let me just go through basically what needs to get done. So we're gonna get rid of the load cell. The load cell was just sort of a fun curiosity thing. I like doing that because you can collect some data and you can do some testing. And we were able to produce, we don't really need this, an image like this. And we could see the height of this thing. The high spots and the low spots and whatnot. So this is where it's like higher and this is where it's like lower. So that was pretty cool. But we're not going to actually have this be the mechanism. What I'm planning on doing is most likely we're going to remove these counterbores and we're going to build a plate on top of this. And that plate is going to cover this. Because this is recessed, so we're able to do this. So actually, it's actually a really cool design. I was thinking about it last night. What's really cool about it is you can hide the belt. So it's actually a really compact design. And as long as it doesn't rub, it should be totally fine. So that's basically the plan, is we're going to put a plate on top of here. And that plate is going to have... Now, and then I was thinking a big L. So let's just get on TL draw here. So let's see. From the side, I'm thinking something like this. We have this plate here. You know, it's got the notch. Or, well, I guess, no. This is sort of the stack up. This is the carriage. This is the mount for the belt. So this is the belt. So this has this notch and this notch. And then here we got the mounting holes or whatever. What I'm thinking is this comes out like this. And we probably want it to be thick. Probably want this to be a big, thick L piece. And the idea here, let's see, how do we want to do this? Instead of that, actually, wait, do I have Control Z? We probably want it to be like this. The problem is there's a huge bending moment right there. I mean, if this is flush, if we can get this... Well, see, the problem is this is actually like this, and this is... I hate this eraser, bro. But whatever. This is really like this. And so if this is flush... to there, even still, if the force on here is going to cause this thing to bend, so I don't really like that. But anyways, we could then, let's say this is the floor, then we put our rods in here, and then we put our block with our pen holder in there. Okay, and then the question here is what we could do, which is pretty interesting, I guess, is because I want to do a rack and pinion, I think. So wait, but the thing about a rack and pinion that so this would be like that. And then there'd be a stepper here. And I don't know how it would look. It's not going to just plug into there like that, but it's going to have some sort of... It's going to have to be rotated 90 degrees from the top. So I think what I want to do actually, though, to start off with is a passive design. Because there's a lot new here, and I hate taking these huge leaps where you're just like, what is going on? So what I'd rather do, get rid of the stepper motor, get rid of the rack and pinion, get rid of that part. This is like this. There's a pen here. But then on this top part, this is again just going to be like here. So this is like quite similar to... Wait, let's get everything open. Params, tinycnc. We don't really need tinycnc, but basically, it's quite similar to this design in terms of you have this 3-layer stack up, sort of here. There's linear bearings in here. Oh, jeez. I cannot draw to save my life. So there's that. So this can slide up and down. And then the best thing would be springs here. And I have a spring kit that I don't even know where I put the new spring kit. But there's a spring. And the idea is if this thing is traveling this way and it hits this bump, then this spring is going to come up. The problem is, even still, I just don't see how a fine tip, an ultra fine tip Sharpie is going to be able to withstand this. But that's honestly not real. Okay, so that's one thing. Okay, so this is what we're going to do right now, and we're going to just prototype this and get that working. That'll be fun. The next step, though, is we need to make this... First off, we're going to need to CAD out the retractable Sharpie, or get a model for that. And then we're going to need to... Okay, so I don't know. This planning of the steps is quite hard. Where the hell is the README? Alright, so the steps to... So, okay, so the things that we really need to do... Is that actually the date today? No. Is we need to... The crucial thing is testing compliant, non-interchangeable. Right. That's basically what we need to do. The problem is, I guess from the front. Okay, because I do want to have some forward thinking. So this is right. Or it's really left, but, you know, who cares? Who's counting? So we have this thing. So what I was typically going to do is 2 beams, right? Like, just like we had. But I'm thinking I can actually be smarter, because if the back of this thing... If the back of this thing slides on this, then you should be able to use 1 rod and not have any rotational problems. But I kind of don't want to rely on that. I kind of do want 2 beams. 2 beams is sort of like what you would typically have. But then I really got to build this big thing again. I mean, I should be able to... I could probably just use the same part. Oh wait, why did I draw that at the bottom? Whatever. This should be like this. And then we have this part like that. But then there's a backing behind it because we're trying to get low. Let's see, what is the height of this? $76. And what's the height of I guess this? 75. Wow, it's quite similar. But so that means that we kind of want to build it all as one part. I don't really have a problem with that. The only thing that I wish I had done a little bit differently is the parallel dist between... Can we just hide this? We don't really need this. This and this is 0. So, not the best. Because that's why we sort of need to make this out. That's why I kind of wanted to do is 2 parts. If I just commit to 2 parts, we remove the counterbores on these 4 holes. So I think I just left that. Oh no, I did remove that. We can remove this one too. And we... Okay. Okay. So from the top, what am I thinking? We have this carriage. Oh, R makes rectangles? That's nice. Okay, so this is the carriage. And then on here we get... Oh, do we have lines? Nice. Oh, you have to... Dude, what? How do they call this a real tool? You only put down 1? It's the stupidest thing ever. Is there not... Oh, wait. There we go. That's what I wanted. Lock. Okay, cool. Someone thought of that. So, okay, so this is the carriage. C. We don't really need that. But so we have... So we're going to have something on top of here. Let me think. We could recess it. Well, okay, I guess what I want to know is from this face to the ground. Because this thing is so tall because of the rails. But we can actually make it... Because you want to get it as low as possible. Okay. So we got rid of the load cell. Now let's just start again. So we're gonna I think I like making it 2 parts. Okay, I don't know why I'm being so weird. So let's the problem is we have this whole thing. See, this is what's super annoying when you do 2 parts in a part studio. I hate this. Why don't we duplicate this or something? This is like the why care old with load cell. So then we can just forget about that thing. So now we can roll it back. Something like this. Even more. There we go. So let's just delete all this. Okay, so it's 1 part. Let's just remove this whole part. It doesn't need to be here. Okay, so it's going to be like this. And we are just going to sketch on here. And we're basically going to do this. Okay. We kind of want to know how it is in relation to the whole thing. Because what is it? This top to the bottom is 87. So we do want it to go down. Alright, so let me just get some shapes down. I mean, I don't know why I'm being so weird. So if I just do like this, you know, this, and this, and then I just say that these are equal. And then we just do this, yeah, this whole thing. Is this in there? Can't tell. Something seems wrong. There we go. So if I just extrude this by 10 millimeters. Oh wait, but it's a new part. Oh, why is it making, oh. Why is it making two things? See, that's weird. What the hell is that about? Is that it? Okay, so it's like that, except, wait. See, what is going on there? I think it's because I have to use these. Is that it? There we go. So that's kind of what I'm thinking. So this is just the dumbest possible design. So we got the 4 bolts, the belt is locked in, and then let's just get some of the dimensions from the OG, because it's like, why not? This is probably a parameter. I'm gonna get some coffee. Oh my god, there's so many features left, because we need to do that, then we gotta say, okay, now add lifting pen, now add replace, now test retraction, then finally tool changer. So right now, no motor. Oh, dude, this Z-axis is driving me crazy, bro. It's like so much more work than you think. Alright, so let's just get this going, I guess. Okay. The vertical rod, what would I call it? Rod gap. Rod dam. Beam. That's got to be what it is. Rod cent Horus dist. Terrible name. Alright, let's just make it 60.5. So rod cent dist. That's what we're going to call it. Rod cent dist. So we're going to go to here. Was that calculated, or was that just like raw? No, yeah, it's just raw. I wish it would tell you if it's raw or a formula. It should have the little FX thing here, because then you can get a better sense of like whether it's driven or not. Who's even working on Onshape, bro? What? Why is it? There we go. Okay. So so where were we? Okay, so wait, we need to, let's just make this. We're trying to design the stupidest and most simple one. So let's see, what was the thickness of this part? We want to do it like this one. 35.2. I don't know why it's 35.2. We're gonna make it 35. Okay, 35. And then what was the on it? 90. Let's just make it 90. That's not so bad. Okay, but then what was like this 20? See, so that's gonna be the crazy part. Is see, but we don't want to do that. Well, let's just see. It's gonna be 20 plus 32. Yeah. Oh, I guess if we counterboard, but even still, kind of long. What I'm thinking of is maybe we do. Because what I was thinking is it goes down and then it comes like that. So really, it's like, oh. Well, okay, wait, let's just, because it's not like a total disqualification. I think it could work. I mean, we could just recess this whole part. We could just make 2 extrudes, right? I don't know. Then it's going to be weak. It's going to be really weak. But alright, let's just get it going. So we want a circle here. And that's, let's see, we probably have a parameter for it. But let's just hide this, this probably 8.2. So if we go to our variable student, we search for 8.2. We have nothing. Somewhere I gotta have this rod OD, but whatever. Let's just make it 8.2. That's small, man. What's that for? We need to actually remember this geometry. I hated doing this sketch because it was like really lame. So what we really want to do is unhide. If I undo that, okay, cool. So we want to go switch to this and just get the sketch for. I guess we can hide this part. Hello, hide this part. Whatever. I guess maybe... Like, why is it so far over? I think it's arbitrarily in the center. I don't think it needs to be in the center. It's going pretty good. So I wish this didn't take so long, but basically I'm realizing that for all the features we need for this R place thing, it's gonna be pretty challenging. So here's my plan. So first off, sorry, give it a second. Whatever. All right. So the first thing is I'm going to build. So all right. I mean, I don't. Okay. So the first thing is, where am I? So the good news is that it's way flatter, which is great. The bad news is that there's still a ton of work to do to make it so that I can change the pen, and that I can raise and lower it. Because I've never done both replace the pen and change the, and raise and lower and change the pen. That's going to be a huge thing. So right now, I don't know, maybe I could just reuse this crank slider. If I just reuse this design, because the thing is, it's flatter now. Now that the deviation is not, I don't know, I still would like some compliance where I can use a spring to set the force of the pen downward. So I really want to test that out, but it's... Alright, so I think I'm just going to keep doing that plan. So first, we're just going to see if a spring... If I can get a spring... to not destroy the pen tip. Because right now when it's rigid, it just kind of destroys the pen tip. Then we're going to add lifting it. Then we're going to see if, basically, can the lifting mechanism be used to retract the pen. Right, and then we can finally do tool changing. So those are the sort of 4 steps. And I'm trying to do that, I don't know. I got like 5 hours. And I think we'll be able to at least do the first one. Let's just set this in the middle here. You know what I should have done? Okay, so then this is going to go down 10. And then from here, okay. What? Oh, wait, that's too low. Oh, I shouldn't have put it in the middle. Okay, wait, hold on. That's okay, we can do this. Wait, what just happened? Alright, there's that. I don't know why this is erroring on me. Is that really an error? What is going on? Oh, you know why? Okay, wait, I get it. We need to... We used 3s for that. I kind of just like using the 6s, but if it's only going down 10, there's probably a reason why I had that. Okay, fine. So let's just delete this point. And let's just that works. That works. I'm down with that. Okay, now it should be fine. So the M6 is the thread. There's the okay. So there we go. So there's part of it. Then I think I should be able to just reuse this part exactly, right? Is that true? I don't know if that's true. Let's just redesign it. It's not that hard. So basically here, we're going to sketch on here. A rectangle like this. Doesn't have to be a huge part. The only thing is here we need to do this, and it's going to be these LM8. Why don't I have that? Where is this LM8UU stuff? Like, why is this in here? Okay, so wait, let's copy the table. This is so annoying. Copy table, sheets.new, paste it. Okay, then we can copy this. Then we can go to params, go like this, then go like this. Okay, then we have these. So those aren't going to change, so I'm not going to do that whole nonsense with the whatever and whatever. But now we can get the whole thing. So now we should be able to just go to this and update here. Let's see, do I get it now, or do I have to like, okay, linear bearing hole. No, I guess I can just mirror this. Okay, so what we're gonna do here, we're gonna sketch, and then let's see, let's just make this the same as the other one. 35. Is that what we did? So instead of this, ugh. Okay, there we go. All right, 35. That sounds good to me. Extrude. It's a new part. It's gonna be LM8UU height. Okay, then we can just do this. Okay. All right, we are almost there with the pen holder business. So let's just, I've done this so many times. So we're gonna do like circle, circle, 4, This is gonna be 15. Okay. And I'm pretty sure that's it, right? Is that it? Oh, you know what I think we did also? We drew a line vertical like this. And then we did like incident tangent. And then we mirrored that. Do we want to mirror it, or do we just want to do it again? Let's just do it again. So now I can go like this. Put the other way. Merge with part 3. Oops. Wait, what did I just do? And then we're going to make this LMAUU. Like that. We can make it go down more. Okay, so where are those springs that I got? I just bought some new springs. I don't know where they're at. Oh, there they are. The problem is you get a ton of springs and you barely get the ones you want. So these are 10 millimeters, but these seem strong, man. These seem like they're going to destroy the pen. That's the problem, is you want a really thin 1 by 10 by 10. What does this say? 1 by 10 by 30. We need the OD is... Oh, this will work. Well, no, but still, it's too thick of a spring. Let's see. 1 by 10, 0.9, 1, 1.1. These are real tough springs. I want like a half. These things are really strong. They're too strong, really. We just need to be above 8. This could work. Something like this, 0.8 maybe. That seems good. The problem is, and this should go around the rod. Where are those rods at? Let me get the rod. No, because their OD is 10. Oh, fuck. What am I talking about? God damn it. So then how are we going to do this? Where do the springs go on? I really want them to go on the rods. So it needs to be... And these 10s probably aren't going to work. So I guess I got the wrong fucking thing. Because if they're exactly 10, then they're definitely not going to fit. Oh, they do fit. But they... I guess they fit. I guess. Alright, so I guess we gotta try these. But are these the longest ones that I have? These are the 1 by 10 by 30s. I thought there was something... Wait, is it? No. This is 1 by 10 by 25. So these springs... Okay, these are 1 by 10 by 25. Yeah, really... Well, maybe for the just normal fine tip instead of the ultra fine, we won't have an issue. Here's 10.5. 10.5. I think 10.5 sounds like, I mean, because you don't want it to be so small that it doesn't, that has so much friction. Yeah, so that's nice. That's what you want. But this is a really tough spring, so plus, well, I guess we can cut the rods to length. So basically, the rod length would be 24 plus 10 would be 44 at a minimum, plus the travel. So it'd be like 44 plus 25, 44 plus, yeah, because you don't want it default in compression. You don't want it to just always be in compression. You want it to be, so that's probably what it would be. It would be 44 plus 25 if we were going to try to use these springs. Personally, I think that these springs are going to totally mash it. What other springs do I have? Thing is, I don't think any of these springs, like this would be perfect, but I don't think it's going to fit around the rod. Yeah, because these are 10s. Ugh. Who knew that springs would be the hardest part of this thing? Please be big enough. These would be perfect, man. Oh! Okay. So what are these? These are nice. I like these. Wait, didn't I have 4 interesting ones too? 4 more good ones? Where did I put those? Alright, but these sound pretty good to me. Let's see what they're... 3/4 of an inch? That sounds about right. Let's just test it. Because we don't need to raise it. Well, let's see. We'll take that out because we need to know... Because... Hold on. Let me think about this. These are almost perfect. I just wish they were slightly longer. Because... Okay, yeah, they're like 3/4 of an inch. Because the main thing there is... $30 millimeters. These seem longer than that. But there's just no way, unless we use like a worm drive or something really slow, I just don't see how we'd be able to get that to work. Okay. I'm wondering if I should just forego the springs. I keep talking a big game on springs, but like... Maybe it's flat enough as it is. Let's just make this extrude longer. Uh-oh. So that's not gonna work. We, Right, because of the merge. Ay. Wait, so we can't do that. But that's what's so annoying, is like, how do you... Wait, why is it like... What's going on? What the hell's going on? So how do you do this then? How do you take this sketch and extrude this? What if I did new? It still doesn't work? I don't get that. How come that doesn't work? How did I do it before? Oh, I made a little notch. Oh, you make that tangent and then... Okay, wait. Let's just try that. It looks uglier, but we can... Oh, we can do this. Okay, hold on. Okay, for some reason that works. Anyways, that's all good. We're all good. Okay, let's start to put this into the assembly and just get a picture of what's going on. I don't care. Where is the LM8UU? Where is that? Because, see, I feel like params is like my personal standard library. That's kind of how I feel about that. But it's probably modeled in here. Yeah, see, how stupid is that? Is it configured? What? But it is fully parametric. It's just... Okay, so let's just put it in here. I mean, because that's what it is. It's... And then, wait, can't I... Let's see this. Configuration panel. Okay, I think I got this. So this is going to be for the 8. So that is like a saved configuration or something? Is that right? So wait, so let's make a version here. I think that's right. So now if I go to here and I want to insert other documents, params, hold cylinder. Is this right? That doesn't look right. Oh, it is. Oh, so even though I did this and it's configured incorrectly, so okay, but now what I'm curious about is if I were to insert it again and default, and then I just change it to 50, 60, 10, and then I generate it. Okay, good. All right, so this behaves exactly like I want. That's very nice. That's how you should do most things, actually. Okay, good. So now we can mate this to here, and then we can all right, very good. So now we want to insert the rods. And what is the rod length there? It should be configured. So let's hop back over to Z or something. 88.5. Okay. Let's just do that. What is that? Configuration len? I don't know what that means. Okay. So wait, so let me think about this. If we put springs in there, we can shorten the rods. I don't really care about that. I'll just cut some more with the hacksaw. But this is what I want to know. Okay, so here's what you do. You let the pen fall. Then you press up slightly on the springs. Just tiny bit. Then you tighten it down. So then by default it's in slight compression. The thing is, it's going to be really stiff springs. We need better springs. We need like long, thin springs to do that. Honestly, why don't I just try the crank slider again? I honestly think if we just skip all of this nonsense and go straight to the crank slider again. If that's the case, then we can move directly onto replaceable springs. All right, I'm going to go. All right, I said all this crap about the springs, but since we're using... We'll see if it's a problem, basically. We'll see if it's a problem. Otherwise, I'm going to... Because let's try one of these. Where did I put all my pens? Oh, shit. My desk is so messy, bro. Where did the retractable Sharpies go? It's so fucking cold in here, man. Okay. The thing about this is that this is really strong. I mean, the spring on these is brutally strong. Okay, let's just do a test. By the way, I got some big paper. So we're really starting to get to, I keep saying this, but I really think we're getting to the finish line. So, alright, so fuck it, crank slider again. I don't give a fuck. Y'all can suck my balls. We're gonna try the crank slider again. Because I already have that mechanism. And I think that sagging's no longer an issue. So we should be able to just copy this part. This part should literally be totally fine. Alright. That seems good. So we just need to do a couple of features. Alright, so let's just get this done. So we already did that. So we just need to do this whole... Alright, so wait. I'm going to do this. What part is it a part of? What is this called? Servo holder. So I should be able to just look. Servo holder. Wait, that's not right. What is going on? Dude, why does my computer keep freezing up? Alright, this is going to make my life a lot easier. So we just need to know about... So if we switch to this... Let me switch to this. Which sketch is that? That's this. 7.6. And it's midpointed. Okay, good. Wait. No. That's not right. Let's make it 7.6. And how deep does it go? I think it goes 8. Okay. So we go to our assembly. And then... Wait, why does that look wrong? Wait, what? Say what? I don't want to design that part again. I really don't. So wait, we're going to go to, what's it called? Servo holder. Should I just redesign it? How hard could it be? So dang annoying though. Okay, it's just gonna be a so here's what it is. Block. I don't know why it's 35.2. I think that's like an artifact of something random. Alright, so it's gonna be a 35 by 20 by 90. So, okay, let's just freaking do this. Wait, we should be able to do it. Actually, you know what? I got an idea. Wait. There we go. Wait. Okay, so wait. So now that once we have this, we're gonna be able to do some cool. So wait, actually, wait. I want to do this though. I want to roll back before we did all this. I want to do this. I wonder if it does a priority based on frequency of usage. This is so efficient. I really like that. Where you just build the stack up right here so you can reuse all the geometry. Kind of a lot of material. Kind of a solid block, but you know, it's all good. So now we just need to do this sketching. Alright, so let's just move this over here. Okay, so how are we going to do this? We do Alright, I think that's it. Alright, is that the whole thing? Why does this look so much further over? It's because this is longer or something? That's 80. What? That one's 80. I think that's because that's an old one. I feel like that's old. Yeah, this looks good. This looks fine. Alright, so let's just delete this thing. Cool. Yeah, I've been lagging like crazy, bro. Alright, so by doing this, screw compliance. We don't need compliance. Anybody that says they need compliance is crazy. What we do want to do, though, is we want to go to this Z thing. And then I just want to go like this, 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 this. I'm going to find all of these parts. So hold on. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh yeah, there's that too. There's that. There's that. There's that. There's that. Where was that? Where did that get put? Yeah, put it at the end. Good idea, guys. Servo crank. Alright, so now we should be able to just insert other documents, tinycnc assemblies, create a version, servo crank. Boy on that crank. So wait, hold on. I guess this. Wait. The front of it, yeah. Does this have any of the... No. See... There's 2 Revolut mates and I can't seem to... There we go. This is supposed to be Revolut though, right? Wait, what is this? Oh no. I don't know what's going on with that, but it's fine. All right, so we're done, right? We did the whole Z-axis again. Just sort of reconfigured. I guess we need to add one more feature there to make it okay, so we just want to add some counterbores in here that are pretty aggressive, right? I think that's what I want to do. We want to calculate it though, so I want to calculate it. But yeah, this should be working. This should work. Wait, why does this look so small? 4.6, 5.6. Okay, we need to change that. So let's go back to here. This. Ay. This is what it's like 6, 8, 8. Not a bad looking little thing here. I mean, it's so high up though. I wish it wasn't as high up. Nice. Okay. So I should be able to print these parts and we should be able to just start chugging along again. The only thing I guess that's kind of a concern is that I made the cables a little too short, I think. You know what I want to do? Should I add a little thing here? You know what I'll do? I'll add a bracket that can be removed or something. But so, oh no, but you know what? That's not good. Oh. If we get it way lower. No. Because, okay, hold on. Wait. I really don't want to have to CAD this out. Okay. Whoa, someone did a lot of work on that. Okay, so I'm trying to think though, if I put a little ceiling here, I wish we had this slider mate. I need to fix all these mates. These mates are driving me crazy because I can't move this thing. Oh, I can move this. I can move this one. Whoa. I forget if it can move it to the top. Okay, okay, I'm gonna do it. So, I'm gonna do it. So we're gonna design it as. Let's see. I wish I had one to play with. I wish I had a Z-axis to play with, but I disassembled it. Because I want to know... Alright, you know what? Okay, let's just do it. I don't know why I'm being so much of a baby. So, what we're going to do here... And this is going to be weird because it's going to be self-intersecting. Oh, the other thing about this is we're gonna have to use the Dremel to get out this stupid shirt clip. This thing is ridiculous. I'm gonna have to destroy that. That's okay. It's easy operation. Okay. All right. So this is gonna be kind of weird, but here's what I'm imagining. It's gonna be like this, this, this. Let's see. We could do it like... I don't know, yeah. 20 sounds good. We could do it like this. Shouldn't interfere with anything. It'd have to be a threaded insert though. I don't really like... I'm so sick of threaded inserts. They're just annoying. Ugh. They're really, really annoying. I mean, honestly, we could make it go all the way through. No, we can't because the tap isn't that long. We can make it... Oh, you know what we could do? We could just make it deeper than it needs to be and then just go as far as we need. You know what? I'm going to try that. I think we're going to try that. New technique. Little new technique. And let's make it flush. Let's just see if that is going to work. Okay, wait, hold on. Here's what I'm going to do. Oh, wait. 115. Let's fuck it. Let's try it. All right, so let's just finish that and we'll print these 4 parts. All right, so we need to add a feature. Okay. So blah, 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 blah. That door scares the fuck out of me. Oh my god. Okay, so let's back to here. Let's delete the... Let's see. You know what, let's just so we got this thing down. Let's just delete all these. What? Oh no. This is more out of curiosity. We're gonna see. Let's make this 5. So I think we're ready to print. That's cool. So, yeah, we just need to print 1, 2, 3, 4, 5 parts. We just need to print all of these parts. I wish there was a way to, let's see. I don't know why it does this. If I do this, it only does one of them. Wait, what happened? Oh no, give me a zip. Okay. Oh, you know what we forgot? Forgot something. This we need a counter bore. Switch to. What the hell is switch to? Oh, I guess I'm there. I'm in a part studio. So, the problem here is, I want to try point pattern again. So we're going to extrude this and okay, so wait, hold on. So right now we're at like 32 and the depth of that hole is what exactly? Can we go to the rail? Is that accurate? It's 4. So we have 36. So we have 4. So wait, so we want this to be, we want that to be 26, right? We want this to be 26. So we want to remove this by 6. So then this is going to be 26, and then we have 4 millimeter. Or you know what? We should actually make it slightly. Let's make it like 5.5. Oh wait, this is the wrong thing. Maybe like 5.5. Then it doesn't, you know, because the worst is when it like is loose. All right, so now we want to try this freaking point pattern again. Entities to pattern, feature pattern, this feature, reference point, this, locations, this, this, this. Nice. I think that's right. I think I finally got it. All right. Good stuff. Kind of close to the edge, but, you know. Alright, so let's, we just need to re-export this part. Alright, so we just want to, do this, except everything but Z base. Wait, why doesn't it always do this? Allow rotate. I don't know why it doesn't default to that. Just, like, do the thing. Like, I never care about this. Alright, and then we just need to insert one more part. Oh, look at that. Look at that packing. That's great. Alright, let's see if it's going to work, though. Wait, what is that? Oh. Cool. Cool, cool, cool. 2 hours. Ole, are you there? I think what I want to do is start testing. Once I get this all assembled, I want to test if we can get everything working with one color, and then because then I can unblock you. I can do the Cloudflare stuff. Oh yeah. So the main thing is that we needed a machine that's reliable. That's the biggest issue. And so with these two rails now, I feel like I have something that we can run that so once we and I added a very maybe cool, potentially cool mechanism where I can retract the pen. So even though, so even though we don't have multiple colors yet, if we have a mechanism to retract the pen, with this pen has a gasket in it that prevents it from drying out. If we can do that, then we can at least get, start to spread it around, not the full video, not like not the full video, but basically get people to use it. And I can start building a camera mount. Because the thing is, like, dude, making this a really good thing has a long, long tail of shit that we gotta do. Because I need to build a camera mount that gets it right in frame and has good lighting and stuff like that. But if we can get the pen retracting, we can at least build something where people can place individual dots of one color, and that can presumably last for a month, right? Because that's sort of the time scale of reliability that I'm expecting, is that we can get this thing hopefully to last at least a week without any manual intervention, which is way harder than I originally thought it would be. Because even still, the pen tips and all that stuff. And that's aside from ink running out. I don't expect that, there's just nothing I can do about that. But yeah, so give me, since the first rework. Oh yeah, the second rail. I know. Yeah, we needed that. We really needed that. I'm glad I just spent the money. It was like $50 for both of them. I wish I bought those 2-meter ones. Like, imagine, dude, if we make a V2 of this thing and it's huge. That would be awesome. But yeah, so we, multiple colors would be awesome. Multiple colors is still a requirement, but I need to work up to it because it's like all this geometry needs to change. Instead of this, which I've done about 1,000 times, I need to have something that comes down here. Maybe I have like standoffs here or something, and then the servo goes like this and can clench something against the back wall. I'm kind of worried because the spring on this thing is really strong, and what I feel like is going to happen is that it's going to be really hard to get the servo to hold on tight enough. I did buy a really beefy servo. I don't know. Oh yeah, this thing. And this thing is a metal thing, so we can presumably do way more with it. Wait, it said that it came with a metal horn, but it totally didn't. Oh wait, did it? Oh, here it is. Yeah. So if I can use this one's probably strong enough to clamp it down tight enough that it can that it could retract it and click this thing without really causing slippage. Because if it slips at all... Is that threaded in there? Oh, that is threaded. That's nice. Oh, and this uses a set screw? Wow. I didn't even look at this thing. I haven't even played around with this thing. I think I should find out if, I wonder if I can get a CAD model for this. I like that it's metal, though. That's very nice. Well, it's weird that they use a collet, sort of a spring collet, and a let's see, what is this? A Phillips? Yeah. Where's my screwdriver? Let's see if this thing. I want to test this thing out, see how strong this thing is. I mean, realistically, I should do the physics, but the physics is really complicated because it's like, okay, you need to know the friction force of the plastic of this pen. Then you need to know the friction force of whatever I put onto this horn. But so yeah, if this is like sitting like this or something, it has to be pretty protruded because the thickness of this thing is really quite thick. .5 inches. 37 mil by 40. 37 by 40 by, what is this, 20? This is probably 20 by 20. 37 by 42, is that what I said? 37 by 40. Oh, this is a standard size. This is the same size as the other one. It just, I guess it just has way more torque. Anyways, that's all I wanted to say. Hopefully I didn't wake you up. But, yeah, I'm just chilling for a couple hours. I mean, I can start on the CAD, but I think might make some food right now. I'm really excited about this retracting. If I can get this, because the thing is, with these nuts, I can get it really tight. So there's no way that it's going to slip when I tighten these down with pliers. Cool. All right. Yeah. I mean, I'm going to keep the stream going, but I'm not going to be doing anything because I have nothing really to do. Well, yeah, I mean, I do have something to do. I feel overwhelmed by the design space of getting this server to fit in here. The other guy, the How-To Mechatronics guy, has an incredible design. His design is too good. Man, I really haven't been able to break through a truly good Instagram post. Like, the most recent one, it like slammed up to 1,500 views. And then it just stops. Instagram is so bipolar. And the thing is, I really hate Instagram. Instagram gives me the best content, but it's also full of... It just shows whatever, man. It's too much. I don't know why this video died on YouTube. I think sometimes when I go live, it kills the... Ay, ay, ay. So much shit to do here. Honestly, though, I built this so fast. This is such a smart way to build. You know, I was hating on the multiple parts per part studio, but when you have geometry this linked, it's like just saves so much time. This guy did such a good job, man.
Fixed and the sliding part, in a way,
I could do that. I could do that for sure.
that it pushes the sliding part down. This will help the pen to have a better contact with the work surface. Bearings enter the fixed part hole. While installing the rod, we should also insert a spring in between the fixed and the sliding part in a way that it.
Where's the bill of materials? I knew it. It's always the case. So fucking stupid. Don't know what 8? LM6UU. I love bearings. I could just get some of these bearings. Bearings and more rods. Alright. I'm gonna go get some freaking banh mi, bro. I gotta find my wallet, dude. I haven't seen my wallet in like days. Anybody else not be able to find their keys? Anybody else not find their keys, bro? I love buying bearings, bro. You know, I wonder how many bearings Adam Savage has, bro. Or stuff made here. They gotta have so many freaking bearings. Bearings of all different types. I love bearings. I got big bearings. I got small bearings. I got really small bearings. I got linear bearings. I don't have any. What are they called? What are those other type of bearings with the thrust bearings? I don't have any thrust bearings. Is this what I'm talking about? What's the one with the little wheels? Oh yeah, like this. This is for top and bottom rotation, right? I never use these. These are weird to me. I would expect there to be like mounting holes. Like where do you use these? This is the one that I've seen. Bearings are a marvel. All right. Okay. Let's keep this going. 2 hours. What the hell's a shadow? Yeah, I was thinking of doing some chill. I was thinking of playing some Civ 6.
It's finally time for another episode of our real-life Power Armor series. So far, we've built most of the upper body, demonstrating it curling 300 pounds or about 140 kilos, and made an epic heads-up display with augmented reality, meaning even if you lose power, you're still going to be able to see. Speaking about losing power, that's what this episode is all about. How are we going to power it? And is there a chance that Bob's going to just bring along for the suit? As you saw on the TV show, if you lose power, you're kind of screwed. Should we make ours better than that, or stay true to the source material? You guys have been asking some great questions in the comments and giving us some awesome suggestions too. So in this episode, we're going to dive deep on why we've made some of these engineering decisions that we have, like using pneumatics over hydraulics or motors. There's a lot to do, and we've been working around the clock on this project. We're super excited about how excited you guys are about this project, so we're going to do our best to create more videos to keep you guys informed and up to date on our progress. Now, I think it's time I start working on the fusion core.
Now a lot of you are wondering why we chose pneumatics for this project. Well, you see, we could have gone with electronics or hydraulic actuators. There's a lot of factors to consider.
Augment, can you just simplify this a bit, please?
Let me show you. So our three options are hydraulic, electric, and pneumatic actuators. Basically, hydraulic use a liquid, like water or oil, to transfer mechanical energy, and they're extremely strong. Things like our industrial excavator, skid steers, and our giant mechs rely on hydraulics for massive lifting power. Like the power loader that weighs 11,000 pounds and can pick up 7,000 pounds. Or megaheads that weigh 6,000 pounds and can carry its own weight. The big drawback of hydraulics is that they're bulky and heavy. And although smaller hydraulic cylinders do exist, like the ones we use on Iron Spider, all the hoses and fittings are still really cumbersome. Hydraulics are also slow. For example, the lift for our power armor using hydraulics. Yeah, it's pretty underwhelming. And since there's no easy way to store hydraulic power, you need a big, powerful engine in order to run it, like this Caterpillar engine that our power loader uses. So I think hydraulics are best left for large industrial mechs. On the other hand are electric actuators, things like linear actuators, motors, and servos fall into this category. They usually use some kind of gearing to transfer energy and are very fast and precise. Electric actuators are perfect for things like robot dogs, humanoid robots, autonomous lawnmowers, or our CC camera robot. And it's fast and precise because it uses electric actuators. These motors, however, are still quite large, and you need a whole electronics cabinet to operate them. And this thing only has a 22-pound payload. Pretty strong, but not superhuman. The other downside is that motor power is distributed. Imagine that I have one of these motors on each arm. One for my left arm, one for my right. But I only want to curl something with one hand. Well, this arm is going to be doing all the work, and this one is kind of just dead weight. In a hydraulic or pneumatic system, both of these motors could be hooked up to one pump, which means if I wanted to curl something with one arm, all power could be diverted to a single joint. It's literally like in sci-fi movies, when they say, divert power to life support systems, or full power to thrusters. With a hydraulic or pneumatic system, you could actually do that. So overall, while electric actuators are getting better by the year, they're still not at the level of superhuman strength. So pretty cheap for smaller robots. And finally, pneumatics, my favorite option. Pneumatics use compressed air to transfer energy. And they're often used in conveyor sorting, roofing nailers, and truck suspension. Now while pneumatics are quite a bit weaker than hydraulics, perfect. This cylinder can operate at 3,000 psi. This one, 150, about 20 times less. They will still give us superhuman strength. And they're lightweight, fast, and easily back drivable. That allows us to mount them on the arms and still move freely, allowing us to do fine movements by hand with no power, unlike hydraulics. And that's why we decided to use pneumatics for our power armor. And so far, it feels like the right choice. Not to mention that in the Fallout universe, the suit goes oh yeah, that sounds like pneumatics. Alright, so we're doing some compressor tests. First things first, before we test the new compressor, we need a reference point. So, we've got the compressor that's been in the original Call of Duty exoskeleton in here, and we're actually overvolting it. It's supposed to run on 12 volts, we're running at 24. That's almost twice as much power. Let's see how well this one holds up. I've got the pressure gauge over here. I'm gonna pump this thing up to, let's just go all the way. 150 PSI and time how long that takes. It took about a minute to get to 100 PSI, but the sewer runs at 200. Now this compressor can't do 100, so we'll use 150 as a reference point. That is 1 minute and 39 seconds to get us to 150 PSI. So let's empty the system, hook up our new compressor, and give that a test. See if this one does any better. 3, 2, 1. We are at 217 and we've reached 150 PSI. Now, that might not sound impressive, but the cool thing, this compressor is only at 45 degrees Celsius, which means we can push it harder. Try number 3. So this is going to be our bigger compressor, running at 24 volts. 3, 2, 1. All right, minute and 39. About 57 seconds for the first one, and 1:39 for the second one. All right, not as much of a performance boost as I was hoping for. Now the nice thing is this compressor can go to 200 PSI, which means you can get more pressure at the end, but the fill rate...
Bro, why is this video so boring?
Low. Let's see what we can do. This motor right here is only a 550 watt motor. That's not super energy dense, because
This is a prototype rotor for the world's smallest hand-made electric motor. It's the largest component in the assembly, and I made it on a watchmaker's lathe. Here it is sitting on a grain of sand. So let's get cracking, and I will tell you about the motivation for this project. It was originally inspired by one of Richard Feynman's infamous lectures entitled "There's Plenty of Room at the Bottom." In this lecture, he offered a considerable cash prize to anyone who could make an electric motor no larger than 1/64th of an inch cubed. That's about the size of a grain of sand. He thought that this would require the invention of new manufacturing techniques, such as the lithography methods we use today for making computer chips. But a guy called William McLellan decided to take on the challenge. Toiling away on his lunch breaks, he managed to make the motor by hand, armed with only basic tools. This was a truly groundbreaking achievement, and to my knowledge, nobody else has managed to replicate this. So the question is, using similar tools and techniques, can we achieve the same feat? To stand a chance of making a motor at this scale, it has to be very simple. The idea here is 4 electromagnets are attached to a base plate, and the rotor sits between the electromagnets. By energizing diagonal pairs of coils with opposite polarities, the hope is we can rotate the magnetized rotor. My wife Hazel is going to build the drive circuitry using digital electronics, but I imagine McLellan used analog electronics for his motor. During the course of this video, I think it's important to remember just how small this motor is. I've filmed most of the footage through a microscope, so it's easy to forget. For example, the rotor shaft is 90 microns in diameter, which is about the diameter of a human hair. This makes it very easy to buckle, break, or even squash by just measuring it. Now, to avoid this problem, I drilled a 0.1mm hole in a piece of brass to use as a gauge. To part off the finished component, I ground a micro parting tool. But here you can see a problem. The parting tool left a small pit in the centre of the test component. This is normal, but at this scale I don't have the option to turn the part around to face it off, which is the normal procedure. So I decided to try this circular saw, but without space to get a tailstock in to catch the cut-off part, it just vanished into thin air, and not into the beaker as I'd hoped. I tried using a hypodermic syringe to feed in a droplet of alcohol, and the surface tension of the liquid was enough to catch the part, but then I realised the annoying pit was still there anyway. At this point, I decided to throw money at the problem with these electroformed diamond dicing blades used to cut silicon. They are super thin and fine, so I thought would do the trick. To be honest, I wasn't a fan of catching the part in the droplet because the droplet was consumed by the rotating blade and part. And because of this, I was required to continually feed in the syringe at the right rate to form a stable droplet, whilst at the same time feed the blade in at the correct rate to not overheat or break, since these blades are ridiculously fragile when they're used in completely the wrong material and machine, like I'm attempting to do here. This turned out to be too much to handle, and after multiple blade failures I had to give up on this approach. I thought it was time to revisit basic principles and went back to the parting tool, but I tried grinding different geometries until I managed to achieve one that actually worked. At this point it felt like I'd finally nailed it. With my carefully ground parting tool and a hypodermic needle in the tailstock chuck to help support the part,
That's crazy,
I managed
bro.
to produce something I was finally happy with. Now, it wasn't until the test run that I realised this was all a giant waste of time, but I'll get onto that later.
That's crazy.
For now, let's have a look at how I made the electromagnets. Fundamentally, the electromagnets are made by winding wire around a soft ferromagnetic material. After the practice I had at machining small diameters with the rotor, making the electromagnet cores was actually a pretty easy job. The challenge was winding the coils. Remember, you're looking at a magnified image, but the truth is this wire is about 5 times thinner than a human hair, and as such I couldn't see it by eye. Nevertheless, since I'm an optimistic person, I thought I would start by trying to wind by hand. As you probably predicted straight away, this was just not possible. As you
That's
can
a
see
beautiful
here,
shop,
it was not
man.
only too difficult to manipulate the wire, but it was also very easy to break. To overcome this challenge, I began with making a brass bushing to guide the wire, but I also needed a way to swing the other end of the wire around the electromagnet core whilst providing clearance with the wire travelling through the bushing. To do this, I screwed on the catch plate with a custom peg to provide an attachment point for the wire. I then mounted the spool on a secondary tool post. I made a felt spool core which provided a small amount of resistance which is required for the winding process. After that, it was just a matter of turning the spindle by hand with the wire taped to the catch plate, and this worked really well,
Whoa.
until I got to the end of the core and had to lay on another layer of wire on top of the previous one. You can see I attempted this with tweezers, but I was worried I had damaged the wire, so I devised a much better approach. With the rod in the tailstock, I could ensure the first layer of wire was flush with the end of the core. I then applied a tiny amount of low viscosity cyanoacrylate adhesive, basically superglue, with a toothpick before using a hypodermic needle with a flat ground end to push the wire over the top of the first layer. I cut the core off with the tip of some superfine cutters, and because the wire was still taped to the catch plate, I didn't have to worry about losing the part. With just one more part left to make, I was starting to think this might be possible. I made the base plate from brass rod to hold all the parts together, and I left the base attached to the rod so I could handle the motor. I drilled 4 0.1mm holes and put a small indentation in the centre to help guide the rotor shaft. The assembly process caused some headaches. I placed the electromagnet in holes with the toothpick, but debris from the toothpick was causing issues, and attempting to clean this with a toothbrush just made it worse, so I just did my best to work around it. This is the bulk of the motor next to my index finger for scale. To hold the electromagnets in position and help protect the fragile wires at the same time, I used a dab of the same low viscosity glue I used earlier. When I tried applying the droplet, it annoyingly engulfed the coils and then dried before I had the chance to wick up the excess. I was about to start the project again, but in a last-ditch attempt to salvage the situation, I tried cleaning out the centre with a 0.1mm drill bit just held in my fingers, and I couldn't believe my luck when this appeared to work. I haven't put the rotor in yet because we first need to build the fixture for holding the motor upright and the custom PCB to allow us to connect it to Hazel's drive circuitry. To make the PCB, I used the pantograph. This is essentially a milling machine, but I can force the spindle to follow any 2D pathway.
Dude, I really want to build one of those.
The PCB
You could do it on a lathe
consists of a hole
too.
in the middle for the motor to poke through.
That's
and
so
4
fucking
pairs
cool,
of
man.
pads that I can solder the coil wires to.
That thing is so cool. You could 3D print
I
the
found
big
soldering
thing and
this
then
wire
reduce
a
it
bit of a
down.
challenge because the wire itself tended to melt, but when I soldered directly to the PCB, it was fine.
Dude, this thing is nuts.
With the motor connected, I just had to mark the rotor so we could see it spin under the microscope, magnetize it with this Heath Robinson rotating magnet setup, and place it in the center of the motor. I don't want to say how many rotors I lost during this phase, it's just embarrassing, and needless to say, once it had pinged out the tweezers, there's absolutely no point in trying to find the parts. I couldn't breathe during the operation because my hands wouldn't be stable enough, but I can only comfortably hold my breath for 40 seconds or so, which wasn't enough time to safely transfer the rotor from the work surface to the motor. I did invest in these surprisingly expensive special fine-tip tweezers, just so I could even pick the rotor up, which did help a lot, and I did finally get one to work. So let's turn it on. Here you can see the wires are wobbling at the frequency of the electrical signal, which is a promising start, but unfortunately the rotor showed no signs of moving. By this point I had invested several months into this ridiculous project, so I wasn't about to give up now. I did some experiments on the rotor after the test run and realised the rotor had lost its magnetism. In a way though, this was actually good news, because this implied that the electromagnets were working and the magnetic field was overwriting the field I applied with the neodymium magnets earlier. My brother Charlie, who's an expert on magnets, suggested I use a material called alnico. I could only source this pre-magnetised, so I bought a piece and heated it up beyond what's called the Curie temperature, and then I let it cool down slowly to demagnetise it. At this point I assumed it would just be a matter of repeating the process from before, but it turns out this material is just not machinable. You can see here it's been mangled and my tooltip has been destroyed. So I set up a grinding wheel in the lathe and used what was left of those electroformed diamond blades to grind the rotor shape, but now I couldn't use my special parting tool from earlier, so I had no way to cut it off. As before, the diamond wheel broke. So I decided to just try making a simple disc by reversing a chunk of the material in the collet and grinding away the excess, but it simply sheared off as soon as the grinding wheel made contact. Thankfully, the sheared piece remaining in the collet ended up being a disc of the correct size. To magnetise the new rotor, rather than using the silly rotating magnet set up earlier, Charlie pointed out I could just magnetise the rotor by touching it on an N52 grade neodymium magnet, and that's because the component is so small relative to the magnet, we can just assume the magnetic field is uniform near the magnet surface. Now obviously my alnico disc doesn't have a shaft to hold it in place, so I placed a microscope cover slip, basically a thin piece of glass, over the electromagnets and applied a drop of watch oil. This allowed the alnico disc to float on a thin film. I turned on the electromagnets and this is what I saw. Now it's not exactly the eureka moment I was hoping for, but to be honest, for a while I thought it was going to be a lot worse. Now when you include the thickness of the cover slip and the oil film, you could quite justifiably argue it no longer fits within the 0.4mm cube we originally targeted. So I will be revisiting this project in the future with some new ideas. Let me know in the comments if you have any ideas what I can improve with version 2. Earlier in the
That's
video,
a
I mentioned
ridiculous
that I
project,
secure
bro.
and protect the coils, but accidentally applied more than I intended. Under the optical microscope, it is difficult to see exactly how badly the excessive adhesive application affected the device because it's transparent to optical wavelengths. The good news is, the adhesive is opaque to electrons, which means we can use a scanning electron microscope to learn more from our next attempt. I just want to say here a special thanks to the Biomedical Imaging Unit at Southampton for kindly letting me use their microscope. Here is a scanning electron micrograph of the motor assembly next to a standard sewing needle eye for scale. You can see the coils are not very well defined because they're just engulfed by adhesive. If I zoom in, you can see the coil windings at the top, and you may also notice I accidentally broke one of the coil winds during sample prep. You can also now see all the debris generated by using toothpicks to manipulate the coils. Based on these images, I think it's clear that the adhesive has provided additional supports for the fragile wires, but at the potential cost of increased friction on the rotor shaft. I think
That's a crazy video.
Welcome, Cogs. I've designed a brand new bionic hand from scratch, and this time my design has no servo surgery, no resin printing, minimal fasteners, printed parts, and off-the-shelf components. Yet I've still managed to cram in 11 degrees of freedom and kept the proportions very close to human size. This time, I can safely say that this is a robotic hand you can print at home. All the parts can fit on an A1 Mini, the entire finger system prints in place as a ready-to-go system of linkages, and there's no crazy soldering wizardry like in previous designs. In this video, I'll show you how I designed it with the help of the new RevoPoint Pop 3 Plus handheld 3D scanner. But first, I wanted to take a little look back at some of my older designs. I first got interested in building a bionic hand when I was probably around 17. I can't remember exactly what set it off, but I've had a lifelong interest in the human body, and I think that the hand is, mechanically, probably the most complex and interesting part of it. I made a few different attempts before I started university out of wood, but unfortunately I don't have any pictures of those, but I would lump them together collectively as version alpha. Then during university I started a new 3D printed bionic hand which controlled each joint using a tendon system, by which I mean a motor inside the forearm pulled on a piece of string to effectively puppeteer the joint from
Dude, the geometry there is crazy. I don't know how people CAD this stuff, man.
distance, allowing me to get a much more complex and dense design while keeping the power of larger motors. This version beta, has spring in every joint and more fasteners than the plastic car, so way too much and it really didn't move that well, but I did build and test the final version. I picked the project back up around 2020 and totally redesigned from scratch with additional servos for the joints themselves, a much more lightweight design approach and more complex parts using resin. I designed and printed joint servos just to fit within the shape I wanted, and I even had actuators for the metacarpal bones beneath the fingers, meaning the shape of the palm could change and subtly alter the orientation of the ring of little fingers. This design, version Gamma, was extremely cool, but I think it was just too ambitious for that stage in my life given my skill level and other commitments at the time, so I never actually finished a full working prototype. I had a break between the end of 2020 and 2023, and then worked on it very on and off until I finally finished a working prototype at the start of 2024. Version Delta was heavily based on Gamma, but I stripped back a lot of the cooler, more ambitious features. I switched from my homemade palm servo to off-the-shelf ones. I made the palm static instead of actuated, and I simplified the thumbs motion too. The prototype worked, but at what cost? I couldn't shake the feeling that version Delta doesn't really achieve the requirements I set out, and the even worse problem was that my requirements actually aren't very clear at all. Back in 2020, when I still had a Yorkshire accent, I laid out all of my requirements in this video. The main thing that I stressed was that I wanted it to be affordable and easily accessible, so that people could make their own. I would argue that version Delta is too hard to build. My new philosophy going forwards is not to try and do everything at once. If my goal is for a design to be accessible to the general 3D printer owning public, then it should actually be easy to build and cheap. Whereas if I want a design to be highly biomimetic, tackling movements and range of motion not yet explored, then maybe that should be a separate design which might be a little bit more expensive and tricky to build. That brings us to version Epsilon. The number one requirement is that it's pretty easy to make, and the two requirement is that it's not too expensive. In terms of mechanical function, the biggest obstacle to making any of my hands designs achievable for the average hobbyist is the massive amount of actuators, joints, servos, sensors, and wires. So I decided to simplify the mechanical action of fingers to ensure that I need a single actuator. This will mean that there are some objects I can't grasp, but
Um, Does it have more I/O pins? Without needing to recompile firmware? That is kind of cool. It's crazy that the ESP is actually cheaper than the Uno. Isn't that wild? How do I buy this thing? Whoa. How is this thing... What? How is this $48? If you just want to order it from JLC... Is this what I was looking at yesterday? This looks like something else. Oh, this is what I was looking at. I don't really get this thing. What is Tindy? What is 6-pack? Two-layer board. Bro, I can make this shit myself. You know what I like when they say, plus check our schedule. Or is that PIs? I don't know what that means. Please check our schedule. This doesn't look right. But what components are here? Because what I want to know is there a 3D? Okay, so this, okay. I don't know what this is for. So you put your ESP here, I guess. Stall guard. This doesn't look right. What the hell is this double? Oh, I guess there is another. I guess it's a breakout. I guess that's a breakout. Where was the, is this U4? What is this? Is there a search? Because isn't there's all these caps here. I forget what this is, but I'm pretty sure I looked at this. Didn't I look at this? Yeah, I'm looking for this. Where's U4? What do you do? I don't know what that... Oh, that's just a breakout, I guess? That's the funny thing about these boards, man. I don't know what that is. More breakout. Look at these big-ass traces, bro. The step and dirt traces, yeah, those are signal traces. These are... These are oh, I get it. Okay. So what are these, though? What are these type of connectors? Okay. So you don't... Let's see, how does mine work? Oh, it's just right next to it. Okay, that's fine. That all makes sense. I understand. Bro, I'm so sleepy. I went to bed way too late. I don't understand though. Where? Oh, is it on the back? Dude, I kind of want to just order it. I feel like that'd be fucking cool, man. Where is that chip though? Dude, I feel like I should just order this. $30 on these CNC boards. What is PCBA? I don't know. What's the difference between PCBA? I get expedited. Do I want green? I feel like I want blue. Or black. What looks the best? I feel like green is gross. Black looks good. Does black cost more? Oh, if you're gonna get assembly, they give you a deal. So wait, can I see the bomb though? I want to see the bomb. Wait. They assemble it. That means that I get the whole thing, right? Save $30. It's fucking awesome, man. That's if you're getting a 6-layer board. So what am I doing here? I'm gonna get 5 of them, so I could build 5 CNC machines, bro. Kind of sick. I remember doing some thermal calculations on the copper weight. Pretty nuts. 1 ounce copper is weak as hell. Single and double-sided placement. Wow, look at all this. How much does it cost? It's so funny. If we were to do... Oh, yeah, economic. But what about board cleaning? It's free? So what's the total price? Surface finish? What is that? Nitrogen reflow? Dude, there's so many options, bro. So what am I going to get? I'm going to get this, right? It has all these things on it. I don't even know what these I/O modules are. So it's gonna be $12 plus. So it's gonna be like $30. But yeah, so that's what was weird is like here. Wait, what? Oh. What does 6-pack mean? You don't actually get 6 of them. It's kind of weird, right? I don't really understand how can this be more expensive? Oh, look at this board though. This is a different board. Is it? I mean, I would definitely prefer this. You know what's weird? Okay, look at this. Look at this. They did exactly what I did when I was building when I was designing my PCB. You put these headers here and you just constrain their distance. It's so weird. But so you don't get these other boards though with it, right? Like all this. Like what is that? This uses plug-in modules. So I don't know if I want to buy this because it doesn't come with any of the... Oh, there's U5. It doesn't come with any of the fucking... It's kind of weird. Set an alarm for an hour. We just gonna chill, bro. We just gonna chill. I don't know what else to do, so. Plus, I have a graphics card, bro. I don't know what the... Let's just go random leader, right? Let's go random. Difficulty prince, sure. Let's go quick, right? I like big maps, though. Are we just gonna play this for... The thing is, I kind of want to get to class early, so I'll only have, like...
From the first stirrings of life beneath water, to the great beasts of the Stone Age, to man taking his first upright steps, you have come far. Now begins your greatest quest. From this early cradle of civilization on towards the stars. Heroic Frederick, King of the Germans, Your task is to forge the independent states that surround you into an empire. You are blessed to be a great military leader. Use those skills to bring these cities under your sway.
Oh. Copper. Let's see, is there not a like more top down? What? Whatever. Alright, we might as well settle. Oh wait, hold on. What are all those settings? How do I get the... I want the resource, but I think there's more. I thought there was like 2 or 3 settings that I really needed to enable. Wait, let's just see. Where's my settings? Quick combat enabled. Alright, let's just see short research amounts. Well, let's found it and see if it does it. No, yeah, it doesn't have the, Oh, it's R. Wait, what? Is it R? Why isn't it showing anything then? What? Oh, it's Y. Tile yields. There we go. I don't even remember. We need to get mining, I guess. Thing is, I'm kind of botched in here. So what's mining? Let's get mining. We need to build a worker, right? The thing is, the builders are weird, right? Because the builders get consumed, which honestly is like kind of a nice mechanic. Alright. We good? Oh my god, we are like trapped in here. Oh, okay, never mind.
Behold the wonders of the heavens and earth. The clear aqua blue serves.
We gotta get that, dude. That's sick. Alright, we gotta get a new...
When you find yourself in a
Okay, wait, what do we need? We need to get a, we want to get writing. Let's get pottery. Oh, we can't get a settler with that population? Oh, see, that's brutal. Okay. Should we get a scout? Wait, what does culture actually do? I'm pretty sure culture gives growth, right? Oh, wait, here's a city. Or is it just food? Oh, culture you like you like purchase upgrades with, I think. Let's get a scout. We need to build a city here.
No man ever wetted clay, and then at his best, man.
+1 gold in the capital, +1 production, double experience for recon. We gotta expand the borders. We got no food, man. Oh, we have pottery. Should probably buy it. We should probably get that. I always like speccing builders, but trade route's also good. The trader. Trader is nice, actually. Because we can just do inner... what does this mean? Can be boosted, improved 3 tiles. 30%. Let's do this one and then the other one, I guess. Or do I not get the opportunity to do that? Oh yeah, let's get this fucking thing. Oh Jesus, is that a scout? Okay. Minor victory, alright. Oh. Faith? What's that? Spices? What do we want? We want this. Or should we build another one? What is that? 1, 2, 3, 4. 1, 2, 3. Is there a benefit to... Oh, we want to get that one, actually. That one's going to give us the most fastest. We can come up with the other one. Maybe. Not sure. Is that it? We don't even need granary. Why do they want me to build a monument? Oh, so we can speed up this stuff? What about food, though? Loyalty, too? I say granary. I say we get the food.
I am fond of pigs.
I am fond of pigs. Oh no, a desert? We gotta get a... Let's see here. We want writing, I think. Plantations plus 2 gold. Builders to embark, that's nice. I said we go writing. We gotta get science so that we can get like money and stuff like that. I kind of overly spec science all the time, but I feel like it's smart. Ooh, oh fuck. Alright, wait, we need to build a... Let me get out of there. Because we need a... Oops. What happened? Oh, we met someone? Oh, city state. Okay. We gotta retreat. Gotta build a warrior. So many spices. Pantheon? What does Pantheon mean? From camps. holy site. I think we want this. Marsh. I don't know what defines... If I hover over this, does it say? We're probably going to build a bunch of plantations, right? If we spec culture, we get all those upgrades faster, but... Healing? That seems kind of good, actually. City growth rate is 10% higher. That seems pretty good. Get out of here, man. This is a builder.
Without craftsmanship, inspiration.
Realistically, we want to do this, right? Because we're gonna need to build like more builders than that. This warrior needs to go over here. This guy needs to go here. This guy needs to back the fuck up. Oh wait, can we put... Oh, I might have just boned myself. Let's see. I don't really want that. Wonders, unit maintenance, government plaza. I think we want this. We want trade. We want to trade between ourselves. Settler. Do we want to... Yeah, we want to just pump out settlers. Oh, it auto-switched the scout. That's nice. So we should get a ton of food right off the bat. Oh yeah, and the era score. Oh yeah, so we're good on that. We get a... Yeah, we get a golden era. A great bath. Okay. Monument. I feel like we want that. Oh my god, I can't even move. It's just... We have no room. Can I buy? Just to use him up. So first off, the warrior. Let's come here. But this guy probably is going to take this guy. Alright, it's kind of a gamble. But if he takes this guy, then... Yeah, that's what I thought. But we still can... He's going to run away, but... It'll be okay. I think it'll be okay. He doesn't have 2 movement or anything.
Writing means shit.
Okay, the scout. We want currency, I think. Harvesting a stone. Reveals iron. It's not bad. Should we do this just so that we can... Because we have so much fish and stuff. Damn, it's either running away. It's so fucking annoying. Also, it was dumb of me to make the settler there, but I guess I had to. Oh, see, I lose out on some of that, so that's kind of ill-planned. I probably want to put it there. Why am I low? It's kept saying minor victory. Well, if he attacks me, then I attack him and I win, so it's okay. We needed science. I'm gonna do this. Fuck. God, they're such sneaky bastards. I knew that was gonna happen. I should be able to chase him with the scout because he's so low. Does he get passive? Does this... See, that's not going to work. So just... God, that's so annoying, dude. Why do
That's
they...
the positive aspect.
Why can they do that? Why are they allowed to do that? I don't really want to change that. I think I'm good. See, okay, the scout is so stupid because it's like, why... Oh, and there's generation here. It's so stupid. I'm so boned. I just lost the builder. What a dumb gamble. Okay, let's see. What can we get? Reduce the cost of purchase. I love purchasing. That's why I spec money, actually. Yeah, I love that policy. Let's do this. The thing is, we really got to expand into here. So I need to build a... Alright, so let's just... We've fully explored this, right? Ooh, citrus. Alright, let's get... Let's just do irrigation really quickly. Do we want... I always get bamboozled by that, man. He's gonna run away from me. There we go. Thank God. Okay, so we got it back. Oh, we got our campus. Envoy, I don't even know what that means. This guy's gonna die, right? We give up our scout. We need to just... whatever. I wonder if I can run away. We unfortunately need... Slinger galley. Can we get the fish boat? Oh, Jesus. Another settler? Where am I even going to put the settler? Here? We need a warrior. I forgot about envoys. New mechanic in this game, I guess. These guys don't attack, right? They just hover? Ugh, he's so dead. Oh, I just gotta build... Oh, fuck. Wait, hold on. Oh, that's a scout. Okay. Let's do this. The scout doesn't take the guy, right? Oh, jeez. Wait, does that doesn't have a... Does it? Alright, send this guy up here. He's gonna defend. Are we building... We're building a warrior, but... Oh, I have another settler. I guess I gotta protect him. Let's get the campus off the bat, right? Oh, I didn't even see that. Should we defend this? We need to go... Yeah, let's go defend this city. This is for this city. Okay, I think we're in the clear, actually. Yeah, let's build a settler. Wait, I can go in?
Look back over the past.
Let's spam it, baby. Oh my god. Wait, hold on. Can we buy a warrior? Or is this guy coming down? This guy's coming down. Okay. So it shouldn't be taken. We gotta get this guy out of here. And then this guy will be healed up. Okay. What does he give me? I think we just want to spec that. Do we want to boost my So I should be able to just go over there, right?
I'm also interested.
I want to go grab that, and I want to grab this. So wait, hold on. This guy is going to here. Make dedication. What is Eureka? Eureka is like a science thing. Didn't I? Oh, I got bronze. Alright, plantation, then currency. I don't see any iron. Do we see iron? A copper. Oh shit. But they can't take... Oh god. We gotta hurry up. Okay, we need to build a we need to build a warrior. Spearman. Six turns versus 4. Wait, did they capture him? Wait. No, I don't think archers can capture. Can they? Or am I just gonna lose this guy?
I like to say I
Oh,
practice
dude, I'm so
militant
bad at this fucking game.
mysticism.
Any of the
I'm absolutely
barbarians can
sure
capture
it's
except for the
something that I don't
scouts.
quite know.
Whatever. Whatever. How are we gonna even get that guy back? We're gonna have to come back this way. Wait, let's first grab the thing. Ugh, I totally botched this. We should have a plantation by then, so we should be able to, let's see, buy this tile. Wait, can we just buy a warrior? It's kind of a huge... We just gotta do it, I think. A slinger. Fuck it, never mind. Barbarians are so fucking annoying.
Thousands have lived without.
Sure, let's put it there. And we're gonna put another one there. Finally we get currency. I don't have a library yet. Let's build another settler. Ugh, okay, whatever, let's go here. Get luxury. Oh my fucking god, I'm so sick of these goddamn guys. He's trapped. You're trapped, bastard.
It is equally important.
Ugh, there's another one. I'm pretty sure it's supposed to go political philosophy. We gotta get this settler back. Wait, what did I just do? What did I just do? Oh, that's fine. Is that fine? No, I think we want to go back to this. Plot harvests. Builders. To grow this city. It's actually already grown so fast. Is this guy full? Wait, where did the other guy go? Wait, we gotta send this guy back up here. There's no route to get back up there. We can't go back in there. That guy's completely trapped. Oh, there's a barbarian encampment there. Fucking god. This guy needs to get out of there. That means that we need to... Why did I build another settler? Barbarians are so goddamn annoying. What is this? Is this guy... Oh, this guy's a warrior. Hell yeah. I'm gonna beat up on you, bro. How many, might as well. Oh, there's more there. Alright, send them down. We should be able to get 2 more out of this. They're fighting that. Alright, I think we're going to be able to get this. Oh, there's definitely a, what's it called right there. There we go. Fuck yeah. Come on, let's go help him out. Just do it. We gotta get this guy out of the way, though. Ugh, I mean, he's gonna die, but that's okay. Oh, so they captured it. Okay, cool. So this guy can just come back up here. Wow, he dies in 1. Do they take a...
Money.
Money.
A physician without a knowledge.
Harvesting of crab? Should probably just get that. Where's the settler? I thought I had one more settler. This trader. I thought we had, where did the settler go? I guess I sent him down. Kinda dumb, but okay. I guess we can get one here. This one, maybe. Let's get a builder. Start improving all this stuff. This guy He's got to go up here and protect. That sounds good.
And all I ask, politics is the art of...
I don't know why the hover didn't work. Alright, here we go. We got settlers. We probably want to make 2 more settlers and then switch. We probably want to do this. Sure. Wait, how did I get so low? Ugh, we gotta survive. Wait, that was a scout. That wasn't an archer. What am I talking about? I bungled that. Stone. Let's get the masonry, because I think I saw some stone.
Each of us is carving a stone.
Look at a few. Allow all some bark. What is a harbor for? Crab for gold. Let's do this one. Okay, the print is almost done. Warrior, let's do him fortify. Got a builder, nice. This, let's just Whoa!
There is nothing but a
What the fuck happened? Where did all these motherfuckers come from? Hold on. Stay here. Stay here. Alright, let's just do that. There's so many warriors. It's such a drag, bro. I don't know. Oh, they can embark now. Let's see if we can get over to here. Oh wait, the builder?
may the forces of evil.
This builder? What the hell can this builder do?
If bread is the first necessity of life,
We've got to kill this encampment thing. Heidelberg. Let's buy some tiles.
no hour of life is.
Wait, did my guy die? Did he just get freaking aggroed? Send this guy over, bro. Come on. Send this guy over. Send all of the warriors over. They're not doing anything. Just gonna spam warriors. We're just gonna kill all these guys. It's so annoying. They just keep fucking spawning. Wait, what happened to this guy? Oh, he's so fucked. We can't even go that way.
We're all apprentices.
Just fucking run in there with some horses.
Without mathematic defense is
Just build a builder. He'll go over here, he'll work all this stuff. Oh god, wait, what? Might as well. Or what about a commercial district? See, what is the research? That's what I want. That for the production. We are gonna fucking kill you guys. Oh, wait, actually, let's get those turtles. What am I doing? How do I just get out of this? Just vote on all submitted. There we go. Wait, where's the other horse? The 23 turns into that? I don't think so, man. Whatever.
The 4 building blocks of
Major defeat? Fuck it. What? I want more trade. Major defeat? Dude, fuck it.
It is the mark of an
Pardon me.
Just like, what? What are you talking about? Oh, okay, wait, hold on. Just one more turn, bro. Just one more turn. Alright, what am I doing? Workshop? Oh, wait, increase trade route capacity? We need to get commercial districts on all of these guys. Wait, can't I? Oh my god,
has
dude.
both a tradition.
Great Admiral. Maybe I should be using...
Betwixt the stirrup and the...
Oh, he's gonna die. Dude, we need to just buy a thing. Dude, I really fucked this thing up. Did I finally do it? Oh my god. The world is good. What do I do?
With the advance of feudal...
Ooh, this is super good. Two extra build action. That's pretty good too. We finally did it. I need a naval unit. Come on. Ugh.
There are very honest people who do not think that they have had it.
What does this fucking guy do? What are you supposed to do with this guy? Just wander around?
I don't underrate them.
Motherfucker.
The poets have been mistook. You're the... I've lived through some terrible things in my...
Damn. Let's see, what do I need? Alright, let's just go get the printer. I'm done. I'm ready to save, bro. Oh, wait, we should get factory, though. Alright, whatever. I'll save. Save game, save game. Next disk. Alright, let's finish this thing up. I'm gonna get some water too. Okay. Let's do it. Okay, so oh geez. That's not good. Well, anyways, this part's done anyways. I knew I should do 4 millimeters. I should do 3.5. So wait, we'll do this temporarily. Easy. What did we say, 30s? $30. All right, M3 by 30s. There's probably some in here, right? Whatever. Oh, I got it. Oh yeah, that's rock solid. That's good stuff. Um. Okay, so we'll let that heat up. Um, I should have done a blind. Seems good enough. Oh, these are fours. Wait a minute. Does it matter? We're gonna have to make these wires longer, unfortunately. Maybe not. Hey, you know what we forgot? The thing about this is, this thing is so stupid because you can't take it in and out. I didn't even think about that. How the hell are you supposed to get it in? Once I get it in, though, I want to test it out. Alright, so let's put the pen in. Alright, so hold on. Let's use the other pen, the one that's... Alright, so I guess this is what you do. For right now, this is what you do. Get this out of here. Let me go like that. Okay, now let's just... Look at how fast that thing turns white. That's actually amazing. Do you see that? It turns white when you bend it. Not enough. Not enough. Alright, I'm gonna go get the Dremel tool and just do it. See is, yeah, that'll do. Alright, let me go turn off the light. Alright, so wait, did I just break it? No, it works. Alright, cool. Alright, so let's just see if it works with the motor. Okay, so we got 3 cables here. We've definitely lost the... We don't need this anymore. This is old news. Okay. Get some water. It looks good. I'm getting so fast at CAD, bro. Alright, let's just do it. Come on, I really want to see this thing work. Okay, so, 1, 2, and then where's the, Actually, would this work? Male to male? That's not a bad idea. And we get some more room. I thought I saw a 3 by male male. Anyways, let's just get another set. Wait, but we need to know. Okay, 5 volts is right there. Oh, but you want them as a set of... It is. It's white, black, brown. Okay. Let's just do it. So first off, let's unplug this so it's not powered. And then it's going to be... Oh wait, I fucked this up. This isn't right. Damn it. Okay, never mind. Alright, let's just use the little ones. So where's my screwdriver at? Oh, and here's this. Okay. Yeah, this is still pretty... Oh, here's the yellow. Okay, great. Alright. And now I've lost the black. What the hell? Where did that go? I literally just had it. What the hell, bro? Whatever, I just saw another one. Okay. Black is number 2. This goes to the Z plus. Okay, so now we can just hook this up to here. So we got black. Wait, is this right? I don't remember it being like this. It clearly is like that, but why is that so janky? Whatever, let's see if we can make it work. Alright. Okay, so we're just gonna have to do more wire babysitting. So let's turn on the power. Whoa. How did that happen? Pen 0. So wait, we need to change the pen 0 to something else. Setup. Pen. Where's pen 0? Where do I find that setting? There we go. There's pen 0. Let's make pen 0 like 40, 50. Okay, let's. Okay, so it's instead of pen 50, let's go to 60. $70. Okay, so 65. Okay, 60. I don't think I clicked apply on that one. $65 is it. But it's not actually doing it, right? It's clearly pressed. But something is weird with this whole thing. Okay, we need to go more. Oh, there we go. Hell yeah. We did it. Okay. Okay, so I designed this little Z mechanism. It's basically the same as before, but I did this little flap at the top. Check this out. So it's a retractable Sharpie. Now it's open. You can see the tip. Now it's closed. The retractable Sharpie works. Let's go. The retractable Sharpie works. All right, let's try to freaking draw something, right? So let's do pen 0. Okay, and now let's try to delete all this. Okay, let's do dick butt. Okay, let's Y offset 20, X offset 2. Okay, scale by Y to 250. Or no, this is gonna be 200. So the Y max, hold on. I don't think we want that. I think we want to make it 180. We could rotate it. All right, let's just try it. So wait, let's do pin down. That seems pretty good. Oh, it shouldn't do 0. Wait, but that 0... Does that 0 seem kind of aggressive to you? It can do it, though. So wait, why is it why max just oh, you know what? I didn't home it. Not bad. I have a feeling that there's no way that the stepper motor without serious gearing could So, I don't know. I still feel like gearing is probably necessary just because of, or not gearing, springs. Why am I always disappointed with my creations? Here, wait, let's do this. Okay, so retracting pen works. That's good, but I still think it's applying a little bit too much pressure. So what I'm gonna do, loosen this slightly. We're gonna get the paper under here. Go to the highest spot. It's like somewhere around here. Not pressing down at all. Okay, so let's see if that works. Pen up, pen 0. Okay, so that still works. Can we just try it again? Oh wait. Abort. Play it. has a really hard time with the fucking. Also, why does the M30? Oh, okay, hold on. I think I just answered my own question. Where do we get to see what the M30 is? How do I see what the Alright, so what do I do now? What do I do now? That's the question. I hate that I printed it green. I should have printed it gray. It looks so much better gray. All these bright colors, I actually cringe. 4:20. Oh shit! I gotta get going. All right. So it's cool that this works. So what I'm going to do is I'm going to put this over there at some point so that I can get it in and out, but then it still has a place where I can click the pen. But it's nice to know that these normal MG995 servos can handle that. I am worried though because I don't think that the stepper motor without gearing is going to be able to do that, but then the Z-axis is going to be slow as hell. So really, that's a big unknown. You know what? I know I'm not supposed to do Elon right now because it's not that hot water, but like, this is by far the best one that I've ever done. It's just so good. The detail, the rasterization or whatever, all of it is so good. I just want to attempt it one more time. The thing is, you know what I want to do? I think I want to draw a box so that I can fit the page easily. So what I want to do is draw a box. So, let's just say, just do this. This will be easy. So okay, wait, hold on. What's up, Riley? Check this out, bro. Check this out. This is sick. Okay. Pen 0. Pen up. Now it's sticking out. I got this thing freaking... Now it's unclicked. Clicked. Unclicked. Clicked. Unclicked. Bam. Or wait. Clicked. Unclicked. Bam. Easy. Alright, so let's just do this. I love that this thing is here. This thing is so sweet. Okay, so wait. Z-axis, bro. Z-axis. I'm not a nerd, bro. You're the nerd. Why you hate Thursday? Yeah, I know. I wish I didn't have class right now. Okay, wait. Let's just do this. This isn't the size of... Oh, you know what? I'm at A4 paper. Wait. Wait, is this... Wait. What the fuck? Why did I do that? Hello? Let me delete this. Okay. So first off, let's home it. Wait, no, oh my fucking god. Ugh. This is so annoying. I can't believe I did that. I gotta put the clips back on. I'm back to tape, man. That should be good enough. We only need 2. All right, so let's do is that what we want? No, we want the image. Hold on. Height needs to be, let's see, because it'll be 2. Let's see. Hold on. Okay, so we can go to 220. So we need it to be, so the dimension, okay, all right, I got it. So first off, vectorization 0.3, height is going to be, sure, 200. Whoa, why is the feed rate so fast? The feed rate is mad fast right now. Please don't hit the edge. You're back. I'm doing a test print, bro. I'm gonna do this test print and then I'm gonna leave, depending on how long this thing takes. I gotta leave in like 20 minutes no matter what. Or I gotta leave in like 10 minutes because I gotta change. It's not a dick butt. I want to see how it does on the solid blocks. Oh, I forgot to mirror it. Oh no, I don't need to mirror it. What the hell am I talking about? I used to have to mirror it. Yeah, I'm printing this thing. Oh, that's nice of you. Yeah, Jar's better than me, too. It is doing the thing, yes. I gotta go to class in like 5 minutes, but I really want to see how it does in the solid blocks. Yes, I need to get some googly eyes for sure. I don't know why it adds these little dots. I mean, I know why, it's just annoying. I need to clean up the image. Maybe it looks like he's a little bit of magic. There's a magic around him. He's a little sparkly. Is it quieter? It's a little quieter. There's still a bunch of... Dude, I was realizing this. If you want to make a product for real, you got to do so much work for thermals, for sound, for all sort, for installability. It's crazy, man. I know, I need to fix the wiring. Because the thing is, I keep having to babysit this, and I don't know what to do about it. Well, that's good. Well, that's great. And it does seem significantly more robust, honestly. But I want to try it on the long pole off the top. Oh yeah, that's what they do, huh? Like this, right? Keep it out of the way, yeah. That is what they do, huh? Fuck. Okay, wait, I'm gonna go get dressed and then I'll come back.
doing well? What's up, Jeff? What's going on, bro? Where the fuck is my backpack? Alright. Dude, it's not even close to done, bro. I wanted to get a time lapse of this thing. Let's see, I got 8 minutes. I go to community college because I'm a fucking bum. Which axis do you mean, Riley? You can't say x-axis if you consistently say the wrong axis. This is the y-axis. This is the x-axis. Which axis do you mean? Okay, you actually mean the x-axis? Okay, that's good. Alright, well, I gotta just chill. I found my wallet, which is nice. I lost my wallet. Dude, I lose everything, bro. I can't keep that shit. I know, I should really stop cursing. Riley, you always looking out for me, bud. You always looking out for me. W's in the chat. W's in the chat. A fiberglass pole bent in an arch attached to the z-axis, and one of the corners would work good for the wires. W's in the fucking chat. Dude, I want to see it do the solid colors, bro. I'm not gonna get to see that. But this is the best one I've ever made, I think. This will be a good time lapse. W's in the motherfucking chat. It doesn't seem like it's skipping that many steps or anything. It seems like it's actually pretty close to... I'm actually really surprised. This thing is doing pretty well, man. But I want to see it do a solid block. It's like, when are you going to get to the good stuff? Jeff Weber, bro. I've never seen this guy before. He's new. Jeff, if you're still here, you better subscribe. You better subscribe. Hit that motherfucking S. Hit that motherfucking S button. I know it can do one. I don't know. It's going so slowly. Oh, hell yeah, Jeff. What are we at? I think I'm at 331. I'm trying to get to 350. I'm thinking of, guys, I'm thinking of doing this. I'm thinking of ordering this PCB, and what'll be sick is I'll be able to send jobs to it like wirelessly, because I'll switch from an Arduino to an ESP32. I'm thinking of buying this thing. This is the best job I've ever done. It is looking really good. You can even almost make out the words, which I've never been able to get before. Fluid NC, exactly, yeah, Fluid NC. That's what I want. Alright guys, I'm gonna have to end it here, unfortunately. I'm gonna let the print job finish, but I gotta run, and I don't want a bunch of dead air on my stream, really. Not that I have ever not allowed that in the past, but when I'm gone, it just seems weird. Alright, peace out, guys. Thanks, Jeff. Hopefully see you soon. You know, did you know if you say the word subscribe for someone who hasn't subbed? I saw that, but I thought it didn't work all the time. Like, it only works sometimes. But yeah, I did see that. But I didn't know if it's for lives. Does it work on lives? Alright, guys, I really gotta run. I'm gonna be late. See ya. Bye, Riley.